We have already learned how to differentiate using trigonometric transformations. We have learned derivatives of inverse trigonometric functions, and today we are going to learn differentiation of implicit functions. What for? We are preparing ourselves for the third exercise of NCERT textbook, that is exercise 5.3. So this is going to be the last topic. So today we are also going to finish off differentiation of implicit functions. So before we really begin, what are implicit functions? That we will get to. Let's try to learn a little bit of implicit functions. You may already know, but maybe let me just give you a quick recap. So far, what the functions that we have been doing so far are all explicit functions. Explicit. Today we are going to learn implicit functions. What were explicit functions? Functions which can be expressed completely in terms of another variable, where you have two functions, so where it can be completely expressed, are called explicit functions. And those functions where one variable cannot be completely expressed in terms of the other variable are known as implicit functions. What did you just say, sir? Don't worry, I'm going to give you the definition also. But with that, before I really give you the definition, let's see for ourselves what is the difference between implicit and explicit functions. We know examples are the best ways to learn. I've given you here two functions, number one, number two. Let's try to find y in both the equations. Alright, let's try to solve this. So here, I'll take y common. So I'll be left with 1 minus x squared, and x cube I'm going to take it there. So y is minus of x cubed upon 1 minus x squared. So here you can see that I have been able to completely transform one variable with respect, one function with respect to another function, one variable. That means y can be completely written as a function of x. So this kind of functions are called explicit functions. Explicit functions, where you can represent one function with respect to another function, one variable which completely, so two sides completely having separate variables. We can do that. Let's try here. Let's try to again find out y. So I'll take y common, so y will be y squared plus 3ax is equal to that side minus x cubed. So y becomes minus of x cubed divided by y squared plus 3ax. Now you will see that it's not really possible for me to completely express y in terms of x independent of y. It's not possible, or the other way around also. X also, it's not going to be completely that simple. So now this kind of functions will be called as implicit functions, where you cannot completely just represent y as, so here y, I cannot write it as a function of x, isn't it? I'll have to write it as a function of x and y. So this kind of functions are called what? Implicit functions, and this explicit functions. Alright, so now the topic that we are going to be doing today is how to differentiate them, this kind of implicit functions. Explicit functions that we have been doing, for example, so far you have been getting equations like this, y equal to x squared, so derivative of y with respect to x is how much? 2x. Done. Job done. How are we going to differentiate this kind of functions now? That we will learn today in this video. So I'll give you some examples as always. Not much, don't worry. So you can just, but before that, let's try to write on what we mean by an implicit function. So you can write on a function of the form f of xy. A function of the form f of xy is said to be implicit. Is said to be implicit. Is said to be implicit if it is not. If it is not possible. If it is not possible to express let's say y. If it is not possible to express y in terms of x, or maybe like entirely entirely in terms of x. So these kind of functions will be called as implicit functions. We talk of x and y, not only x and y, the variables can be different also, z also, p, q, r, s, t, u, v, w, x, y, z. It can be anything. Generally we talk of x and y. Alright, so you can note down. Done? Alright. Now, how do we differentiate? How shall we differentiate implicit functions? So there's nothing new to be learned here. We will just see how we differentiate implicit functions. So I'll give you an example. Let's say example 1, that is differentiate. Okay, differentiate, let's say x cubed plus y cubed plus 3axy equal to 0 with respect to x. With respect to x. Now, do you remember chain rule? Of course you remember, sir. That was done in the beginning. Good. We are going to be using the concept of chain rule only. It's very simple. Don't worry. It's very simple. I'm there. No, I'm going to tell you. It's going to be very simple. But yeah, you just have to remember some basic concepts. That's what is very important here. So now when I start differentiation, dy by dx, this function x cubed plus, I'm going to start from the basics, 3axy equal to 0. So derivative of x cubed plus derivative of y cubed plus 3a, I'm going to take out constants, na, xy equal to 0. Alright, now simple things, let it remain simple. So derivative of x cubed, and that too we know, 3x squared. Now you see what happens here is, see, x squared, when you differentiate with respect to x, what happens is it is 2x, and then of course even if you follow the chain rule, then x with respect to x, derivative of x with respect to x, so that remains 1. So that's why, you know, that's done. Nothing comes, no remainder term comes. But now the problem will be this. You remember chain rule, isn't it? Now if you differentiate this, okay, if you differentiate y cube, remember chain rule, outer function, inner function. So if you remember this chain rule, then what is derivative of y cube? Derivative of y cube, yes, just following the concept of chain rule, that's going to be what? 3 into y squared. Simple as that. Right, but since we remember the chain rule concept, this is not x, isn't it? This is y. So we extend using chain rule dy by dx. Now dy by dx cannot be solved completely, so that will remain now. You have to be careful there. So you have to identify the variables. Of course, we are differentiating with respect to x. As I say, the variables can be different. It can be z also. It can be other variables also. So you just have to remember that it's about the chain rule. Here, just for your concept, here, see, even if we apply chain rule, as I said, derivative of x cubed is 3x squared, and derivative of x with respect to x, this is 1. So that's why we don't write that. It's 3 into x squared. Done. Job done. But here we follow the chain rule. Why? We know. We already know what is chain rule. We are just applying the concept of chain rule only. So we know that this is not x. So derivative of y cube, yes, as usual, we will be following the same theorems. That is 3 into y squared to 3 minus 1. Then, following the chain rule, we'll have to again differentiate the inner function, isn't it? Remember the outer shell, the inner shell, you can check out those videos of chain rule. So, we have to take out this and differentiate using the chain rule concept. So, dy by dx. Now, dy by dx cannot be solved any further. Not possible. So, it will remain. Similarly here also 3a, now of course here we'll have to use product rule. That's going to be x into what? Dy by dx plus y into dx with respect to x equal to 0. So this is what we'll have to do in the first step. After that, of course, for solution, what you will do is now you will solve these equations and separate them and find dy by dx. That's the basic rule. So just 2 rules involved here. Do not forget the chain rule with the concept, because with respect to which variable are we differentiating, that is very important, so that the chain rule concept can be used. So now let's simplify this a little bit. 3x squared plus 3y squared. What happens? dy by dx. I hope you've got the concept here, isn't it? Why do we write this? Remember chain rule concept. Remember, for example, root over of 2x. So how do we differentiate this root over of 2x? It's going to be 1 by 2 root over of 2x. But since this is not x, I mean like this. Since this is not x, we take this out. We take the inner function, and then of course we differentiate. The same thing that we are going to do, we are doing here also. Okay, so it's not a big deal. Okay, don't take it. It's all in the state of your mind only. Okay, so don't think that this is not possible. You know, it's simple. Just that we need to know x with respect to x is 1. So just that we need to know, that's why. So now let's simplify this. 3y squared dy by dx plus 3ax dy by dx plus 3ay is equal to 0. So now dy by dx, you keep it on one side. I'm going to just take common. 3y squared plus 3ax, 12th standard. I'm sure you find this comfortable. Minus 3ay minus 3x squared. So dy by dx is equal to minus 3ay minus 3x squared upon 3y squared plus 3ax. You can take out the value of 3 common and then simplify and cancel also, no problem. But that's not the big that's not our main concern here. Our main concern is how to differentiate implicit functions. Is it any difficult? No, it's same only. We are just using the same concept of chain rule only. So there's nothing much there. Okay, nothing much involved there. Alright, fine then. Let's try some questions. So this is the first question. I'll give you another question. Done? Okay. You just have to be careful, okay? The chain rule, many students, especially with lack of practice, they forget to use this chain rule. So you need to be careful with that. Next question is differentiate. No, let's say if sine y is equal to x into sine of a plus y, then find dy by dx. So we'll have to solve, and so first job is to differentiate using the concept of chain rule, and then solve and find dy by dx. Simple as that. Let's begin. So let's start our differentiation. So it can be done in many ways. So chalo, what shall we do? We can directly differentiate also, not a big deal here. So chalo, let's begin. So okay, I'll just try to use the quotient rule maybe. So I'll just find x is equal to, so by cross multiplying, sine y is equal to sine of a plus y. I'm using the quotient rule so that it can be a revision for the quotient rule also. So differentiating both sides with respect to x. I'm not writing that, okay? Differentiating both sides with respect to x, because I have to differentiate with respect to x. Dy by dx is equal to quotient rule, square of the denominator, then denominator into derivative of the numerator minus numerator into derivative of the denominator. So this is how much? 1 is equal to sine of a plus y. What is derivative of sine y? Of course it's going to be cos y, but with respect to x. Remember, with respect to x, be careful there, with respect to x. It is not with respect to y. See, if it was derivative of sine y with respect to y, no problem, job done, cos y, because the concept of chain rule doesn't apply, because it's y with respect to y, job done, just one function, not composite functions. But here we have composite functions. So what happens? Dy by dx, chain rule concept, minus sine y, again This is cos of a plus y. See, chain rule concept, derivative of a plus y with respect to x, and the denominator sine square a plus y. So if we just cross multiply, I'll have sine square a plus y is equal to sine a plus y cos y. These are just practice questions, as I have said, minus sine y cos a plus y. What is derivative of a? Constant, 0. Derivative of y with respect to x is going to be y with respect to x. So now let's solve for dy by dx. Let us solve for dy by dx. So this is sine square a plus y. This is sine a plus y cos y minus sine y cos a plus y. Common dy by dx. Trigonometry comes into play again if you want to simplify it. Trigonometry, identities. You remember the identity? Remember the identity where we have sine A cos B minus cos A sine B. What was that? Sine of A minus B. You can see here sine A cos B minus cos A sine B. Trigonometry, no escaping, no chance. So sine square of a plus y is equal to, this can be written as sine of a minus b, dy by dx. Y cancels, so I'm going to do it directly. Sine of a plus y, sine a is left here, so I'm going to bring that down here. Sine y dy by dx. So see, basically that's why there's nothing much, nothing new here. Just the same old differentiation. Yes, you just have to be careful with the chain rule. That's the implicit functions. So how do we differentiate implicit functions? We do not need anything special. It's just same old differentiation. Yes, you need to be clear with the concept of chain rule, because we apply the concept of chain rule only. Yes or no? Alright, one more question, another question that's going to be number 3 for today. Exercise questions, practice questions. If y equal to root over of x plus 1 by root x. If y equal to root over of x plus 1 by root x, show that 2x into dy by dx plus y equal to 2 root x. Now you see, you must be wondering, sir, this is not an implicit function because this y is f of x. I understand that. No problem with that. We just have to solve this. But here, of course, yes, you're going to use the concept of chain rule, and of course, yes, it's the concept of how to differentiate implicit functions. So it's, once the concept is given to you, it's not that all the functions are going to be implicit functions only. Absolutely not. You are being just given, given taught how to differentiate implicit functions. Our job is now to put that here, keep that at the back of our head, use it whenever applicable. Dy by dx, remainder term should come. So now let's go for the proof. So for that, maybe we can do a little bit of simplification. That is y equals, I need a proof there, 2 root of x. So maybe if I take common LCM root x, so root x, that's going to be x plus 1. So root x into y. I'm trying to avoid chain rule. I'm trying to avoid quotient rule. So now let's differentiate both sides. So now you see it has become an implicit function. Looks like an implicit function. So, of course it's still not, but it's not about that, okay. So let's differentiate. see the concept of implicit functions, see, that's why it comes here, no? dy by dx. So you will be given functions where you'll have to use that concept. It's about that, dy by dx. Product rule, y into derivative of root x. Otherwise we'll be thinking like, okay, what am I going to do with y? Isn't it? What am I going to do with y if that concept was not given to you? 1 plus 0. So root over of x, because dx with respect to x is 1. But what about dy by dx? It's dz by dx. Isn't it? So if that was not given to you, you will be thinking like, okay, what am I going to do here? But now that is given, you know what to do. Okay, this is it is, what as it is, I'm going to just simplify and solve. Job done. Done. I'm going to keep the proof there because I need to know. Alright, so let me just take the LCM. Let's just take the LCM then. So the LCM becomes 2 root over of x. So here 2 root x into root x dy by dx plus y equal to 1. So this is 2x dy by dx plus y is equal to cross multiplying 2 root of x. Alright, fine, done. Chalo. Alright, so let me give you now a proper implicit function, something like this. Find dy by dx. So that question was like, okay, sir, something, okay. So what about this then? These are implicit functions, proper implicit functions I mean. So if you really want to do proper implicit functions, let's try to do this. Equal to x square minus y. So find dy by dx when sine of x into y, sine xy plus x by y equal to x square minus y. Let's just start the differentiation. So differentiating both sides with respect to x. So I'm going to start straight. Now this is now the 5th, 6th video already. So what is going to be differentiation of sine theta? Sine theta, differentiation of sine theta is cos theta. But we know this is not theta, chain rule, so derivative of xy plus this one. If you wish, we can use y square, y derivative of x with respect to x minus x into derivative of y with respect to x is equal to, this is 2x minus dy by dx. Do not forget to use this dy by dx. Alright, that's where many forget. Chain rule concept, again I'm reminding you. So cos of xy, here of course we'll have to use product rule, x into dy by dx plus y into dx with respect to x plus y square, this is y, x with respect to x is 1 minus x dy by dx is equal to 2x minus dy by dx. हो गया? चलो continue. So let's okay, one more step. Cos of xy, x into dy by dx, this is y, plus, okay, I'm just going to separate them now. Y by y square minus x by y square dy by dx is equal to, I'm going to bring this here, plus dy by dx is equal to, because I'm going to be solving for dy by dx, I have to find that now, dy by dx. So, okay, again, cos of xy into x dy by dx plus y, arranging and writing cos xy plus 1 by y minus x by y square dy by dx plus dy by dx is equal to 2x. Alright, let's arrange. So I'm just going to arrange it like this. Is x into cos xy, dy by dx everywhere, minus x y square plus 1 common dy by dx is equal to 2x. This will go minus y cos xy minus 1 by y. Done, done. Rubbing, rubbing. Erasing. So, alright, let's just take the LCM and just keep things ready. So that's going to be x into y square cos xy minus x plus y square dy by dx, again y 2xy minus y square cos xy. This is just simplification, 1y, 1y. So I'll just directly do. Is that okay? I'm going to just directly multiply now. So dy by dx is equal to, I'm going to do it now, y multiplying. So 2x y square minus y cube of cos xy minus y divided by x y square cos xy minus x plus y square. Got it? So see, you can see it's more about not differentiation, it's more about what? Simplification. It is more about simplification, you know. So yeah, differentiation, it's not very difficult. See, this is just like trigonometry. It's more about your practice, practice, practice. Last question of the day. I don't know which question number is this. I've already forgotten. Lost touch. If these are very interesting questions, that's why I'm giving you. Of course, we'll be solving the exercises via live classes. That's on Tuesday. Is equal to a. Same time. Show that. dy by dx. If you still haven't subscribed, please do subscribe. And please do give me a like also. So if tan inverse of x square minus y square divided by x square plus y square equal to a, show that dy by dx is equal to x into 1 minus tan a divided by y into 1 plus tan a. Tan a. Tan a. I have your tan inverse. So what am I going to do? I will be applying, not multiplying, don't use that term. Applying tan on both sides. Applying the function tan on both sides, so tan into tan inverse 1. So that's x square minus y square divided by x square plus y square. Something like this. So applying tan on both sides. And this becomes tan A. So tan inverse tan, we have already seen from inverse trigonometric functions, tan inverse tan is 1. Ab samjha? We should never say multiplying. Okay, no. We don't multiply. We know that trigonometric functions are not multiplication functions. No. Some may use that term. It's not the correct way to use it. So the job done. Let's differentiate. So, chalo. What is differentiation of x square? I'm going to do directly. 2x. What is differentiation of y square? 2y. What is differentiation of, okay, now tan a, no problem. Tan a is a constant, don't differentiate that again. What is differentiation of x squared? 2x. What is differentiation of y squared? 2y. Right? Simple as that. Job done. No. Did I miss something? Yes. Y. We are differentiating with respect to x. We're differentiating with respect to x. So that's why x square is 2x. That's what many students do, they forget. Y with respect to x. So fine, 2y, chain rule, dy by dx. Inner function should be differentiated. Here also, dy by dx. I did that on purpose so that it can give you a reminder that don't make those mistakes. Many do. Okay, so that's why. So now let's arrange this a little bit. Find dy by dx. So that's going to be 2x, 2y, dy by dx is equal to 2x tan a. Of course, 2 we can cancel, isn't it? Let's just cancel this 2 common. 2 So I think that you can understand. Done. Removed. Y dy by dx is equal to x into tan a plus y tan a dy by dx. Arranging minus y tan a dy by dx is equal to x tan a minus x. So dy by dx is equal to x common, that's tan a minus 1 upon minus y common, 1 plus tan a. So minus can be multiplied here, so this becomes x, this becomes 1 minus tan a divided by y, 1 plus tan a. I believe that was the proof. Alright, so this is how we go for, how we differentiate implicit functions. So, but the basic thing is, like, what are implicit functions? Those functions which cannot be expressed completely in terms of the other variable, completely in terms of the other function as the other function. Functions which cannot be completely expressed in terms of another variable. So how do we differentiate them? It's nothing special, just simple differentiation only. Yes, keep in mind the chain rule, dy by dx, z also. If the variable can be different, just don't forget with respect to which variable are you differentiating, and that is the main important thing here. Alright, so that's it then. I hope you have learned. Do practice with more questions again. So I'll see you in the solution of the exercise 5.3. Now you are prepared, ready for exercise 5.3. Alright, so please, I'll provide you the links of the other 2 videos also. Go through it, get ready. On Tuesday, I'll see you. Alright, till then, bye bye. Take care, stay safe.